So Kyle, here we are, ironically, in front of a flat map.
Yeah.
What do you think that means?
Flat Earth, maybe?
Well, you know, I was thinking about it. The difference between a flat Earth and a round Earth, I mean, wouldn't the physics be totally different?
I would think so. I mean, like gravity, momentum, all of those have laws that obey every time we use them. So you'd think they might be different in a flat Earth.
Hundreds of thousands of scientists have used gravity to explain the world around us. It's one of the most foundational forces known and is the basis for all of physics. Scientists are constantly using it in equations to accurately predict motion. It's helped us predict planetary movements, engineer bridges, and even helped us design better cars. Since God's ways are far beyond finite man, there's a lot about this mysterious force we still have to learn. But because what we do understand accurately predicts the motion of round planets circling the sun, most flat earthers outrightly reject the idea. They claim that since scientists admit that gravity is still a mystery, it probably doesn't exist at all.
There are two different theories people put forth. There's something dealing with buoyancy. You know, heavier things sink and lighter things rise, but they don't understand that actually buoyant forces are well understood in terms of the conventional understanding of gravity. Other people try to argue it's all electromagnetic. So there's an electromagnetic effect. The Earth has a magnetic field, and that's what some residual effect of that is what causes things to fall to the Earth because of the magnetic field of the Earth. Well, the magnetic field varies from location to location on the Earth, so the acceleration of gravity ought to be different at different points. Well, it is, but ever so slightly. It's like 1 part in 1,000 or something, not the kind of thing you would see from the variations we measure in the magnetic field. Furthermore, ferromagnetic things, such as steel ball bearings, they would fall differently than, say, lead or cork would. But they don't. They fall at the same rate because they're all affected by the same amount. So they're just doing a lot of hand waving. I never cease to be amazed how flat earthers will take bits and pieces of different principles and then try to just wave their hands, and they really diss physics in the process.
There are many videos that attempt to show that gravity cannot really exist as we know it. One video features a tennis ball.
They mockingly ask us sometimes, well, how does water stay on a spinning ball? And they show you a tennis ball, and they put water on it, and they spin it around water slings off of it. See, water, the oceans just sling right off of the Earth. Well, they're spinning this thing awfully fast. Try spinning that tennis ball at 1 revolution per day and see how much water slings off of it. It doesn't. And the amount of slinging you get is minimal. It's a tiny, tiny amount if you actually do the calculation right on this, and I've done it. It's not a difficulty. A tennis ball is a bad analogy because it's not gravity holding the water to the ball. It's the cohesion, the tension between the fibers on the fuzzies of the tennis ball and the water there.